Hi guys, so today we are going to see some scaling system design concepts. The first one is a vertical scale. Scale up, make one machine more powerful. How it works? Upgrade CPU, RAM or SSD on the existing server. No code or architect changes required. Work until you reach the biggest machine available. Now let's take a scenario where you have a server which is having a 4 core CPUs. Now you got a lot of requests. So you want to upgrade your CPU servers. So your CPU move from 4 CPU core to 632 CPU core from 8 GB to 128 GB. What are the pros of vertical scaling? Simple, non-distributed system complexity. Trade-offs. There must be a single point of failure. So at any time, if your particular machine will go down, all of your application is going to be shut down. Horizontal scaling. Scale out, add more machine to share the load. How it works? Add additional server behind a load balancer. Traffic and data distributed across nodes. Near unlimited scaling by adding more nodes. So as comparison with vertical scaling, in horizontal scaling, what you are going to do, you are going to set up a new server. Instead of one server, there are multiple servers. So if there is single point of failure to server 1, your data and your traffic is routed to another server, that is server 2 and 3. Pros: no hard ceiling because fault tolerance. Better fault tolerance. Trade-offs: need load balancing and data consistency here. Next is load balancing. Spread incoming traffic across multiple servers. How it works? Sits between client and the backend server, routes each request by strategy, round robin, least connection, or any other algorithm. Detect unhealthy server and stops routing them. Now you have what you have done, you have added more server using the horizontal scaling. Now you want your data to be distributed among those servers. So here comes our load balancing. It sits before our servers, and whenever a request is being sent to a server, firstly it checks which server has minimum amount of load and the data is being sent from that particular server. The information is routed from the server which has a minimum number of load. Pros: high availability, no single overload node. Trade-off: extra hook and the balancer itself need redundancy. Caching: store hot data close by so you don't recompute it. How it works? First, request fetches data from the database. A miss. Result is stored in a fast memory, Redis, Memcache browser. Later requests are served instantly from a cache. A hit. So, have you ever wondered whenever you visited a site, some of the things are being fetched very fastly because they are not coming from the database itself, but they are coming from a fast caching server. A fast caching server may be a Redis server, a Memcache server. So, when you are requesting a data and if it's already present in between these fast cache servers, you're going to be have a hit. But when the data is not present in those fast cache server, it is going to be miss. And the data is being sent to the database to get the request. The most frequently accessed data must be present in the cache. Pros: big drop in latency and database load. Trade-off: risk of stale data without a solid invalidation plan. Database sharding: split one database into many smaller pieces. How it works? Pick a shard key, example user ID or reason. Each shard holds only a subset of the data. Queries route of the shard that owns the data. So when there is a huge amount of data and you have to do the query for a huge amount of database, there comes the part of sharding. Sharding is going to distribute our data in such a way that whenever a user wants the data, we are going to use the shard key to pick up the data in a very constant time. So instead of going through a database fully with the help of shard keys, which is going to work as a hash map, you are going to get your data in a very frequently and a very fast manner. Pros: each shard handle less data and less traffic. Trade-off: cross shard joins and queries get complex. CDN: serve content for a server near the user. How it works? Static assets are cached on the edge servers worldwide. Requests are routed to the nearest H location. The origin server is only hit on a cache miss. So, if you are in India and you are using an Amazon, so your data must not come from the Amazon server from US. It must come from the nearby server of India. So there comes the role of CDN. CDN will get the static content like images, paragraph, text, which is not changing frequently, which are not dynamic. It's stored and it will give to user which are closer to the region. For example, when you open an Amazon website, you will get the data related to India, not related to US. You will get the prices in rupees, not in dollars. That is comes under the part of CDN. Pros: lower latency, less load on the origin server. Trade-off: cache invalidation across region adds complexity. Now let's recap the way to scale a system. We have learned about vertical scaling. This it is also known as scale up. Make one machine more powerful. Next we have horizontal scaling. Scale out. Add more machine to share the load. Load balancing. Spread incoming traffic across multiple servers. The servers which we have buy during horizontal scaling must be used efficiently to make our application highly available. Caching: store hot data close by so you don't recompute it. Database sharding: split one database into many smaller pieces so that when you are going to query data, it will be giving you a fast result. CDN: serve content from a server near the user. So these are the some scale up system techniques. Thank you.